Hi, my name is Jerry Smith. I'm the Vice President and Chief Technologist for our Data Center Solutions Group. And today I'd like to talk to you about Sharable DAS and how we view its role in the data center. So if we look back at storage over the past 30 or so years, if you go back to the 80s and really through into the early 90s, most everything was DAS. Everything was direct attached storage. The storage or the drives were inside the server, and there was generally a controller to access those drives. And it served well for a while, but it has its disadvantages. It's generally an inflexible storage allocation. You tend to get stranded islands of storage, and you don't really get optimal resource utilization. You may have one server that's very busy and another one that's not so busy, so you're not getting as much I/O capability out of your disk drives as you could. And then as we moved into the 90s, there was a big push towards SANs. And this went from the 90s into the 2000s. So you tended to pull this disk drives out of the servers, put those in SAN type devices. And you typically connected those with fiber channel. And over the last 5-10 years, some iSCSI. Brought a lot of advantages. You could go from tens of servers to hundreds of servers connected to the common SAN. And you had the ability to share data between multiple applications on your servers. And you had the ability to provision storage to your servers as your applications needed. And over time, these SANs added very extensive data management capabilities. Thin provisioning, snapshotting, remote replication, lots and lots of very high-end features that became necessary as enterprise applications required mission-critical performance. So then as we got into the 2000s, we really had to shift back into the web cloud type of users where running tens or hundreds of servers on a single SAN was not sufficient. You really needed thousands or tens of thousands of servers all running at the same time. So there was a shift back towards DAS, whereas a lot of the web cloud type of applications, these are the very, very large data centers, went back to the DAS model of shared nothing, where the storage was local to the server. And this was able to scale up to tens of thousands of nodes. But did it go too far? Because it gets back to the point where it really had a lot of the same limitations that the original DAS implementations had back in the 80s and early 90s. So let's take a look at that question. Did it go back too far? And did we swing too far back towards the DAS model as we went to the web cloud? So one of the challenges with the web cloud was, proliferation of server SKUs. So typically a data center might need a half a dozen different SKUs of servers in order to run their applications. And some of those might be high compute, some would be storage rich, and then different blends in between. So you had similar problems with poor resource utilization, where an application running on one server might be running very well, but on a different server, you need more storage or less storage. And once you've ordered it and put that server in place, it's really difficult to change. So your infrastructure tends to be inflexible, and it's difficult to manage the life cycle. If your storage is inside the server, you may only want to rotate your storage, say, every 6 years. But your CPUs, you might want to migrate those every couple of years. But when you have them all packaged together, you lose that ability. And the replication and high availability capabilities that existed in the SANs, those were brought about via the network. So you had data replication across the network, and when a server fails, you have to replicate that data somewhere else. So there's a lot of traffic on the network to handle drive failures and server failures. And so this leaves some performance on the table and doesn't really bring you all the capability that you need. So let's take a look at where we see this going. So if you look on the left side, you've got the traditional DAS model. On the far right side, you have the traditional SAN model. We believe that there's a number of different points in between where different technologies can enable different solutions depending on application need. So we'll take a look at these over the next few slides and dig into them in a little bit more detail. So let's start with the most basic of the models here, and this is really what we just call external DAS, and this is really just taking the disk drives, pulling them outside of the server and putting them inside JBODs, or just a bunch of drives. And you can typically connect one or multiple JBODs to your server, And you can add capacity as you need. You could add more JBODs, you could add more drives. It also allows you to change your CPUs at a different cadence than you would change your storage out. So you might buy the JBODs, you might run those for 4 to 6 years, but you might rotate your servers every couple of years. So it's really the first step towards being able to better manage your resources or your storage and your compute based on the cadence that you need to upgrade those. So the next step here would be, well, what if you took that same basic model and you put, say, 4 servers connected to the same set of JBODs? In this case, you could basically divvy up the disk drives in the JBODs to the different servers. So in this example here, we have a server with yellow volume, and that's using the set of yellow disk drives that are in the JBODs down below. And you could do that either using the drives as just raw disk drives, or you could create a rated volume on top of them, whatever your application really required. But the idea is that you're sharing physical hardware, the JBODs and the connectivity, across a pool of servers. So you could partition the disk drives across this pool of servers, and they would each work only with the drives that they own and provide all the services that they need. So the next step here would be, how can we accelerate this? So what if we just take flash and we put flash, say, on the adapters in the servers, and maybe we also put flash inside the topology. So we have flash or SSDs inside the JBODs, and we have flash on the adapters. Well, now we've got a model where we can run the same applications we've had with the same disk drives, but we put flash and we can transparently accelerate this. So we have solutions today that accelerate RAID controllers based on flash. And this slide is really just kind of showing that by placing flash either in the servers or in the topology, we can accelerate applications. I'm not going to spend a lot more time on flash and acceleration in this presentation. The reason is that this is really more focused on storage, interconnect technology, and shared DAS. And I'm assuming, and I'd ask you to do the same with me, that flash is prevalent across all of the topologies that I'll talk about. So assume that it's there. I'm not going to dig into details on flash, but it's a standard nowadays. So the next step is what we call advanced pooled storage. So this is a similar physical topology as what we saw before. We had, in this case, 4 servers, a couple of JBODs, but instead of partitioning the disk drives and assigning them to dedicated servers, what we do is we let each server take a sliver of its capacity from the pool of disk drives. So in this example, we show 14 disk drives and 4 servers. So we could say every server gets 1/4 of the capacity of all the drives. Well, now, if all the servers are running at the same time, they all have access to 1/4 of the capacity of the drives, they're going to run at the same speed that they would if they had those drives dedicated in the previous picture. But if one of the servers is not running, say it's idle, and you only have 1 or maybe 2 servers running, they get all the performance advantages of all the spindles in the JBODs, as opposed to only the ones that are assigned to them. So it's a way to manage the capacity. You can give different servers different amounts of capacity that you want, but you spread it across a much larger pool of disk drives, allowing each server to run with improved performance if they're the only ones running, or if they're part of a subset. Once again, if all servers are running at the same time, then you're really going to get the same performance you had if they all had dedicated local drives. The next step in the evolution is, well, what if you start sharing storage? So in this topology, all the servers have access to all the disk drives. Well, what if the volumes that you create were shared and could be accessed by multiple servers? So in the example we show here, we show that the yellow volume is actually visible to all 4 servers. And if you think about it, this really is much like a SAN in terms of the access model. You can have multiple servers accessing the same piece of data on the same volume. And then you, of course, can also have volumes that are dedicated to specific servers. Say, for example, the blue volume that we have on the second server, that's a set of data that's private to that server. So there's a couple of things that come along here. Number one is you can run applications that do require shared data across a pool of servers. The second thing that you can do is you can migrate the ownership of those volumes from one server to another. So in this example, the second server having a blue volume, we could move the ownership of that volume and move the associated application to the first server. And we could do that somewhat transparently in coordination with a hypervisor. So if you look at something like VMware, we have the ability to migrate a VM or a virtual machine from one server to another along with its data. The data is still directly accessible by all the servers, so it can follow the application around. The next step in this continuum is, okay, let's bring some high availability capabilities to this solution. Well, now, suppose one server dies. What if we mirror the data from one server to another before we write it? We really have high availability. That way, if any server dies and its application dies, we can move its work to a different server and recover the data that might have been in flight and had not been committed to disk yet. So this really brings in the full set of SAN-like capabilities with respect to high availability and data sharing. LSI does have a product offering in this family, a 2-node version that we call Syncro CS, and I'll talk about that a little bit more in the next slide. Syncro CS is LSI's 2-node shared DAS high availability offering. And I won't spend a whole lot of detail here, but basically 2 servers, each have their own RAID controller, connect to a common set of disk drives, and there's volumes that are shared between the servers. If one server dies, the volume ownership is moved to the other server. So you have a very high availability solution using direct attached storage and getting the cost and the performance of direct attached storage. On this slide, what I'd like to point out is the slides previously really talked about storage, the direct connect, and it kind of infers a SAS type of connection. But the connection to the storage doesn't have to be SAS. And we've architected these solutions, and what we're working on is really independent of the drive interconnect technology. So we could just as easily replace that SAS interconnect with PCI or Ethernet or some combination of all three. Each of the protocols, Ethernet, PCI, and SAS, each has their own advantages and limitations. So you could envision a model where you have a pool of servers that are connected, say, perhaps through Ethernet, and then perhaps you have a pool of RAID controllers that maybe they're common PCI, sharing them together, connected to a pool of disk drives that are SAS. So you can envision topologies where you have 1, 2, or 3 of the interconnect technologies all in use at the same time. The point of this slide is to say this is not only a SAS statement. We're thinking really independent of SAS. We're thinking PCI, we're thinking Ethernet, or perhaps even InfiniBand. So which SAN fabric is best to pool and share DAS storage? So we talked about SAS, Ethernet, and PCI. They each have their strengths. SAS is very good on performance and scalability. Ethernet, performance not quite as good because it has other protocols running on it. It's generally a little bit heavier, but the scalability of Ethernet is fantastic. You can route it around the world. PCI, on the other hand, very, very high performance, but it doesn't scale quite as well. I think PCI probably fits well, certainly for single server, maybe for 2 or 4 servers, maybe up to 8. But PCI really works best inside a single chassis. We don't really think that it scales to the rack, at least as it is today. So let's take a look at some of the objectives that we have with LSI's Syncro product line. And the Syncro product line is all about shared storage. So really, we're trying to develop a common architecture for common hardware and software building blocks that really leverages direct attached storage and shared DAS. We want to hit price performance targets that can't be hit with other technologies. And we want to enable flash and rotating to coexist and use rotating for cold storage capacity, use flash for acceleration. And we're designing this to be fabric agnostic, so we don't really want to care about what the interface is, whether it's SAS, Ethernet, or PCI. And we think that each one has its place in different applications, and you'll see different forms of deployment of all 3 of them. And the final thing is we're really striving to make this easy to manage. So we're looking at single management portals for probably a rack to manage the pool of storage within that rack and across a pool of servers. So let's take a look at some of the demos that we have here at LSI's AIS conference. In the first demo here, we have something we're calling the Super Rack, but it's our Syncro rack scale Sharable DAS architecture demo. That's a mouthful. But basically what we have is a rack that has 20 servers And all the servers have a RAID controller that's connected to a SAS switch. And below the servers, we have 10 JBODs with 200 drives. So we have a model where we have 20 servers with 200 drives. So each server effectively has capacity of 10 disk drives. But what we've done is we create the volumes and we distribute the data for those volumes across all 200 drives. So if we have one server running, he gets all the performance of 200 drives, as we talked about in the earlier slide. When we have a subset of servers running, they get all the performance that are available for those 200 spindles. So we built this up. We have this on the show floor. I encourage you to go down and take a look at this. It's pretty impressive, and it shows what you can do with shared DAS and some of the capabilities and the potential that it has. It's quite an impressive demo. Another demo that we have is what we're calling scale-out virtualization. This is really bringing in our Nitro MegaRAID technology, and Nitro MegaRAID is all about caching and application acceleration. So in this demo, we actually have 4 server nodes, each with an LSI Nitro MegaRAID controller with built-in cache, running Windows, and they're all connected to a common JBOD through a SAS switch. And in this case, what we're demonstrating is the performance improvement that you get with caching using our Nitro adapters, and we're demonstrating VM migration across the servers. So once again, that's 4 servers connected to common storage, and we're able to migrate VMs across the pool of 4 servers. So key takeaways from the presentation. We see a significant opportunity in delivering the right shareable DAS solutions for the market. There's a number of different ways to deliver shareable DAS, lots of different options going from the simplest just sets of JBODs to sharing those JBODs, pooling the storage and sharing the pooled storage, and then bringing high availability to it. We're actively investing in technologies across this continuum because we believe this is a good growth area and a good technical solution for storage needs. And finally, go check out the demos. They're pretty awesome. I think you'll be impressed. Thank you very much.